looks like he's like experimenting something. Like you're doing a physics experiment. Okay, anyone want to comment? What was this guy doing? There's a term for that actually. So what was he doing? He was trying to, and because of what? What's the reason behind this action? Just for fun, just to practice. So it has to do with our lesson today. And mind you, that watermelon is quite far away. It's not near. It's not close range. It's a sniper. Obviously, he's doing some kind of calibration. What's the purpose of doing this? Found the actual gearing or what the scope, right? And then, what's the rationale behind the testing? Anyone? Yes. Some of you maybe next time you'll join the ADF. You might be assigned to be a sniper. Who knows? So why? What's the reason behind this? Why must he do this? No one? Okay, it has to do with projectile motion, which is this topic. Many of you may have this misconception that the bullet flies in a straight line. Or maybe not. Very good, which means you have a good concept of projectile motion. Because once the bullet is fired out from the barrel, you have no more control over it. It will be controlled by what? It will be affected by what? Gravity. That's the only thing. And air frictions, yes. But let's say if there's no air frictions in our syllabus, we will discount air frictions. So once the bullet is out from the barrel, it will be affected by gravity. And the longer it flies, the greater the effect of the gravity. Because what's gravity? Gravity is a form of acceleration. So when the bullet is out from the barrel, it's actually in a free fall. The reason why it looks straight is because it flies at a very high speed. And in a short distance, it might look straight. But if you let it fly for a prolonged distance, the curve will become more and more obvious. So, what happened just now? There's a term for that. It's called, he was trying to zero his scope. Right? Because he knows that this is a professional. He knows that the bullet is flying as a projectile, which is a parabola, which is curved. It's not a straight line. Therefore, if the object, the target is very far away, the trajectory of the path of the bullet will become more curved. And if let's say you're just aiming at these locations, because that was a new weapon. A new weapon, and also the target, he doesn't really know exactly how far it is. So he has to calibrate. So you know that next time you ever become a sniper, every time you have a new target, you have to adjust the scope. Right? If the target is very far away, you have to adjust again. You have to keep adjusting the scope so that you're zeroing the target. So this is the purpose. Sometimes your target can be very far away. Like this is a report done by a Ukrainian. Furthest ever. The target was about 4 kilometers away. That's really far. So the bullet is actually very curved. So that was what he was aiming at this point. But the first shot, the bullet is here. Why? Because of gravitational pull. And I believe obviously there was a very strong wind. So as you have learned about resultant vectors, right? Resultant force. So there's a force, the weight due to gravity, and I guess there's a strong wind. So even though he was aiming at this location, the bullet actually missed him. Therefore, he was trying to calibrate the scope to zero it, so, which means it must be zero over here instead. So you probably lower a little bit of the scope so that the scope is not parallel to the gun barrel. It's slightly tilted towards the gun barrel, so that is like this. Therefore, when he aims again next time, he's actually aiming slightly higher. And I believe he also tried to calibrate so that the scope is calibrated slightly to the right also, to counter the wind. So what's projectile motion? Projectile motion is physics of an object launched into the air following a parabolic path under the influence of gravity alone. So of course there's aperture, but in DC syllabus we will not, we will discount the effects of aperture. So you don't have to worry about apertures. Just worry about that, gravity. This is the answer I found from the internet. The scope and the gun barrel, they are actually not parallel, especially if the target is very far away. And the snipers, they usually have to go to the area much earlier than the target to try and fire a few shots first to calibrate. If you have watched that movie, you may know. He was trying to kill someone, and he actually, before that, he booked a hotel. And hours before the target arrived, he tried a few shots to calibrate. Every time he had to do this, right? So the bullets are actually flying upwards a little bit. So the bullet is like a parabol. So they are not parallel. But if you keep prolong this, they will actually meet one day. Yeah, make it exaggerate a little bit. So they are not parallel. So this is a problem. Let's say if you have if you zero your calibrations very nicely, that is only for the target for that distance. If let's say you have another new target which is further away, you have to calibrate it. Or nearer, you have to calibrate. So you see, this is calibrated very nicely for 200 meters. But if you're using the same calibrations for a target 300 meters, you miss. Because the bullet is a projectile. It's not straight on. Gravity in this chapter plays a very crucial role in projectile motion. Okay. I'm sure you have seen these 5 formulas already. Right, these are the 5 kinematics formula crucial for projectile motors. And also there's another one, but I guess you're very familiar with it. S equals to Vt. But this formula is only valid when what? This formula is only valid when there is no acceleration. So only when your object is moving at constant speed, then you can use this formula. So under the influence of gravity, your object is not moving at constant speed because there is acceleration. There's always an acceleration downwards. Right, please take down your notes. Whatever you need to write down, please write your notes. So you need to apply these formulas because there's an acceleration, which is g. That's why there are some textbooks, they don't write this formula as such. They will replace the a by what? They replace the a by g. So instead of writing the formula as s equals to ut plus half at squared, they will just write it as gt squared, which is very common. Because the acceleration in projectile motions, in the context of projectile motion is g. Okay, there are 4, basically. There are 4 types of projectile motions in the syllabus. The first 2 are relatively easier. Basically, it's just free fall. So free fall, this one is free fall with a horizontal speed. Usually these 2 questions are, these two types will come out in the multiple choice. These two will be in your section B. Structured question. So what are these two? These two are projectile motion with an angle. Anyone haven't received these notes? Anyone? No, you got it? So these two, what's the difference of the third and the fourth? Okay, maybe I'll just show you a short video clip, show you the difference between the third and the fourth types of projectile motions. So, actually, strictly speaking, this is also the fourth. That's okay. So these type of projectile motions, the third type is you start from the ground and then the projectile will land on the ground. So it's a complete parabola. Same level. You start at this height, you end at this height. Okay, so this is the third type of projectile motions. The last one is the starting point and the ending point, the height is different. For example, basketball. Because the thrower doesn't throw the ball from the ground. It's thrown from a certain height.
I really know what he was saying, and then Jordan of a series
and the target is about 3 meters, or more or less, from the ground. So there's a discrepancy. So these type of projectile motions is not a complete one. And the height will be different. So this is the fourth type. Usually this is the most complicated one. So these are the 4 types of projectile motions you need to master. So we'll have examples to help you familiarize with these 4 types. So let's start with the first one, which is the easiest. A helicopter delivering supplies to a flood-stricken farm harvest 100 meters above the ground. So a package of supplies is dropped from the rest. So the helicopter is just hovering over there. Then someone just drop it. Okay? He's not throwing. He's just letting it go. So in this case, this is like a what? Like a free fall. It's like this. So the only effect over here is the weight caused by the gravity. And we know the distance traveled will be 100 meters. So question number 1. Calculate how long it takes the package to reach the ground. So how long do you think we'll need for this package to reach the ground? So okay, what do we know? We know that the helicopter is here and the ground is here. So this thing will fall for 100 meters. This is what we know. What else? Nothing else. Your job is to find out the time needed for the object to fall 100 meters. Now, which formula do you apply? So I have listed down all the formulas that you can use. Which one should we choose? Obviously, it has to involve time, right? So we cannot choose this one. And then it involves acceleration, so I don't think we can choose this one. Can we use this one? We can't. Why? What is V? V is final velocity. Okay, so whenever you have accelerations, what will happen to your speed? If there's an acceleration, means your speed will be changing. It's either faster or slower. So there's a beginning and there's the end. So V stands for what? The final speed. U is what? Beginning speed. So what does it mean U and V? Let's say T is from 0 to 10. So when the time is 0, my speed is U. When my time is 10, my speed is, that's what it means. But we cannot use this formula. Why? Because we don't know how fast it will be at the end. That leaves us this formula. Okay, actually, these two formulas are exactly the same. The only difference is what? Whether you are going against the gravity or you are going with the gravity. So if let's say you are just falling, we are using this formula. If you are being thrown up, you are using this formula. Why? Because if you are thrown upwards, you are against gravity. When you're just free falling, you're with the gravity, so you plus. So very obvious, we have to apply this formula to find out the amount of time needed to fall 100 meters. So let's write down the formula as equals to ut plus half gt squared. You can use AT, doesn't matter. I prefer to write gt. What's S? 100, correct. S is 100. What's U? U is a beginning speed, right? So the helicopter was just hovering, not moving, hovering. And then just drop. What's the beginning speed? 0. Because initially, U is called an initial speed. Initially, it is not moving. So U is 0. So U is 0, this is just 0. Plus half, what is G by the way? What's gravity? You should memorize already, 9.8. 9.8 times T squared. Do you think you can find T? Yes, because this is the only unknown in the entire formula. Okay, find T now. How much is T? I think it's 4.5. Have you calculated 4.5? So, what does it mean? It means for an object to free fall 100 meters, it would take 4.5 seconds. Let me give it in context, so which means, you know Eureka Tower and CBD? That's about 300 meters. So you go to the 100 meter height, you let go of something. It takes around 4.5 seconds for that object to hit the floor. So you can memorize the value, which means it takes 4.5 seconds for something to fall 100 meters. Now this is universal, okay? Discount the effect of air friction. Okay, so that's the answer for question A. So next time you try bungee jumping or whatever. Let's say the fall is 100 meters. It will take about 4.5 seconds. Now B. Calculate how far from its original positions the package has fallen after this time, this time, this time, this time. So as the time is increased, will your distance increase? Yes, right. The longer the time takes, the further you will fall. What's the formula? Same formula. But now you have to put the values into a table. Okay, put them into a table. Use the same formula. So the time would begin from 0.5. U is what? What's U? U is always 0 in this case because it's just free fall. So this formula can actually be shortened into just this. Half gt squared. And you have only one unknown, which is the time. So just keep substituting different time, and then you can get a table. I think we are rushing, so I'm giving the value now. So as time increases, the distance traveled will be more. But if you notice, these distances are not increased proportionally. Why? Because it's a parabola. So as the time increases, the distance traveled actually increases. Okay, what do I mean by that? Let me show you a picture. Every second you fall, the distance traveled becomes longer. Make sense? Why? Because it is a kind of acceleration. When you fall, you are actually falling faster at times plus. Every 1 second, your speed increases by how much? By around 10, which is 9.8. Every 1 second you free fall, your speed increases by 9.8. So let's make it 10. So the first second when you drop, for the first second you travel at 10, then 20, then 30, then 40. It gets very quickly. So which means by the third second, you are already traveling at what speed? 30. And do you know how fast is this? This is approximately, this is actually more than, slightly more than 100 kilometers per hour. So next time, if any one of you ever thought of jumping down from a certain building to end your problem, think about this physics. Just the third seconds, your speed will reach 100 kilometers per hour. Right? I think they have interviewed some people who committed suicide. They say, will you try again? Most of them say no, because it's too scary. It's too traumatizing, that kind of experience. By the third second, you're already traveling at this speed. All of them regrets. They will not do that again, because it's too scary. Yes? Okay, we will not talk about terminal velocity over here. We just focus on projectile motion. Okay, Chuka just mentioned a term called terminal velocity. What is terminal velocity? I'll just briefly talk about it now. Terminal velocity happens only when you fall from a very, very, very great height. Why? Because if you fall from a very long distance, the effects of air frictions will be more pronounced. But if let's say it's just a short distance, like a few hundred meters, the air friction is not very profound because you're not that fast yet. The faster you move, the greater will be the air frictions. But you don't have to worry about that. Why? Because we will discount air frictions for our cylinders. We don't have to worry about that. And if let's say you discount air frictions, then actually feather and apple, they will fall at the same rate. This is a picture taken in a lab, in a vacuum lab. They take out all the air, and then they let them free fall. So it doesn't matter how heavy you are or how light you are, you will fall at the same rate. So in an environment where there's no air, the feather will drop like a bowling ball, just as fast as a bowling ball. You might have this misconception that lighter object actually falls slower. It is because of what? It's because of air frictions. Right, like a piece of paper, the reason it doesn't fall very fast is because of air frictions. But if I crumble it, it will actually fall just as fast as a rock. Okay? Because now the air friction is not obvious. Therefore, it doesn't matter how heavy you are, how fast you're dropping depends on what? Depends on gravity only. So whether you're a piano or feather, they drop at the same rate. Now, try this. See whether you can do it by yourself. It's a similar question to what you just did. It's just that I changed the camera. Camera is dropped by a tourist from a lookout and falls vertically to the ground. The thud of the camera hitting the hard ground is heard 3 seconds later. So which means this camera has been fallen for 3 seconds. Let's say this is a cliff. So this is a trick when you're doing physics questions. If you don't understand, do some drawing. So the camera is here. Then drop. I don't know the distance. That's what exactly you need to find out. So you don't know the S. But you do know the time taken. You know how much time it took to drop. Is it possible that you can find out the S? What formula should I use? S is equals to, actually, the most common formula in projectile motion is ut plus half gt squared. And in this case, what's ut? 0, because your starting speed is 0. You just let go. Because I don't think a normal tourist will do this to the camera. Right? Most likely is he just let it, he drop it accidentally. So So the starting speed has to be 0. Therefore, this formula is like this. Okay, so I have the time. I have the gravity. Can I find the S? Of course you can. So once you found A, how do you solve B? So now they ask you, just before the camera hits the ground, how fast will it be? Right, I think you should know, because you have studied physics already for 1 year. As the camera is falling, it should get what? It should become faster and faster. So when will the camera be the fastest? Just right before the contact is made. When the contact is made, usually it will become 0. That's when you lost all your energy. But right before it hits, how fast will it be? That's the question. So have you found out what's the value of S? Equals to half times 9.8 times 3 squared. How much is this? Huh? 44.1. Let me check right. Yes, I think it's around 44 meters. 44.1 meters. So how do you find B? Which formula should we use? Now look at the 5 formulas. Which formula should we use? You are looking for the final velocity. Final is the V. We're looking for V. U is 0. And you know the time. So which formula? Obviously, this is the best formula to use. V equals to U plus GT or AT. V is what you're looking for at the very end, how fast the camera will be. U is 0 plus 9.8 times. So that will be your final speed, or final. Is that clear so far? I hope it's not too overwhelming yet. This is just the very beginning. We are only dealing with the first type. We have 4 types. Okay, this is only the first type of projectile motors, which is the easiest, which is free fall. So free falling is actually a type of projectile motors. I think most of you have got the answers. Do you get these 2 answers? Next. Okay, the next one is also a type of free fall. But this free fall, you already have a starting speed. So your U is not 0. But your U is horizontal. Okay? Your U is not 0, but your U is horizontal. Like, just now was just free fall. Now it is, this object is moving in this direction at a certain speed, let's say 10 meters per second. So what will happen? It will drop. But how fast it drops, will it be affected by this speed? How far this object is dropped, will it be affected by this value? David, do you think it will be affected by this value? How fast it dropped? Okay, I can tell you now, it will not affect how fast it drops. Because this velocity is horizontal. So it has no gearing with the vertical component. So it will drop at the same rate as something just free falling. So even though the starting speed is not 0, if you are looking at it vertically, the U is still 0. Okay? Because if it's moving like this, you can take it as there are 2 U. Ux and Uy. Ux is 10. What's Uy? 0. So therefore, if you're calculating the vertical part of the motions, you can still take it the US zero. You're not very convinced? I anticipated, so therefore I show you this video clip. This video clip. Oh. Found on YouTube. Okay, I think it's good. This one is launched with horizontal speed. This one is just free fall. But they will reach the ground at the same time. Okay? Remember this. So, okay, they will reach the ground at the same time. Because for this object, the uy is still 0. Even though this one is 10. Okay, because this velocity will not affect this velocity because it's 90 degrees. It will only affect this one if it is not 90 degrees. Then you have a component. 90 degrees, you have no component. Okay, let's come back. This question. Same, I couldn't find a jeep or a helicopter, so I found a B-2. B-2 is a bomber. So this context is very similar. So if you look at it, you see, from our point of view, these bombs are what? Just free falling, right? Why? Because I believe the cameraman is flying in another airplane at the same speed as the plane. So in their context, these bombs are just free falling. But if you're someone on the ground and you look at this bomb, what will be the trajectory? It's actually a curve. Okay? From someone in the plane, this bomb is just dropping vertically. But from someone on the ground, these bombs are moving like this, which is a half projectile motion. Okay, so this is actually a form of relativity. From whose point of view, you get a different answer. Okay, from someone in the plane, it drops like this. But from someone on the ground, the bomb will drop. Okay? So now this helicopter is now moving. It is not just hovering up there. It's moving. At what speed? At 20. And it is still 100 meters above. Now they want to calculate how long will it take. How do you calculate? So like what I said just now, the vertical motions, will it be affected by the horizontal speed? No, right? Therefore, you can actually just treat it as a free fall. So which formula should I use? Calculate how long it takes. Say, same formula, S equals to ut plus half gt squared. What's S? 100 meters. What's U? Is U 10? Is U 20? No. This U is what? This U is a UY. The 20 meters per second is a UX. Therefore, what is my U? Still 0. Plus half times 9.8 times t squared. What will be t? Actually, you don't need to calculate. It's the same answer as the previous one, which is 4.5. I think some of you have already memorized that. If you free fall 100 meters, it will take around 4.5 seconds. The answer is 4.5 seconds. But what's B? What's the meaning of B? What's the range of the package? Because this object is flying like this actually. When you drop it, it will forwards. So therefore, this is defined as the range. The starting point, and then when it hits the ground, what is this horizontal length? This is what we call the range. How to define range? What formula should I use for range? Now let me ask you, your horizontal speed, how much is that? In this case, sorry, 20. Are you accelerating? Are you accelerating horizontally? No, you are not accelerating horizontally. Horizontally, you're just moving at constant speed. So what formula can I use? Constant speed. Distance equal to speed times time. Because you're moving just horizontally at constant speed. What's the speed? So R equals to what's the horizontal speed? 20. How long have you fallen? 1.5. You just calculate. That's your answer. Okay? So this is the second type of projectile motions. Object flies out at a horizontal speed. 1.5, I think you've calculated this already. As for B is 90. Right, the textbook is still using this formula, no problem. Because why? Because the horizontal motions, what's the A? 0. You have no horizontal accelerations. So the A in this context is 0. Therefore, if this is 0, your formula is back to speed times time. So if you think this is too complicated, doesn't matter. Just use this. Fine. Questions before I move on? Anything you want to clarify? Second? The rain is very soothing to hear. Okay, next one I'll just let you talk because I think we're rushing. Now this is exactly a projectile motion, a parabola. Okay, parabola. And this distance, as you can see, is exactly as the same as the previous free falling. Because when you're free falling, because when the object is only moving horizontally, there is no vertical component. So you're exactly similar to the free fall for the vertical distance traveled. The only difference is now this looks exactly like a parabola. Yes. Now let me know if you have any questions about these tables. This is the amount of time taken that you're in the air. Your vertical distance. So if you check this table, it's exactly the same as the previous values. Exactly the same. Exactly the same value. But in this case, you have a new column. This is what we call the range. If you stay in the air for a longer period of time, the range will be longer. All good? So we have just completed the examples of the first two types of projectile motions. Free fall, free falling with a horizontal speed. These are the first two, which is simpler. Okay, now try this question by yourself. This is the second type of projectile motion, which is something that we have just discussed. If you not understand, draw a simple diagram. A ball is thrown horizontally at a speed of 40. Okay, so it's not just free falling, but it's thrown up at a horizontal speed. And it takes 4 seconds to land in the water, something like this. And the time taken is 4 seconds. And resistance, taking note. So now they want to find the S. What is the height? So which formula do you use? I think the same formula, right? S equals to ut plus half gt squared. Okay, by now you should be quite familiar with this formula. What's u? It's u is still 0 because this is only the vertical component. And the vertical component, the velocity is 0. So the ux is equal to 40, but the uv was 0 in the very beginning. Okay, u is 0. But as time goes by, this velocity will keep increasing. So S is what we're looking for. Half times 9.8 times 4 squared. That will be your answer. And then how do you find the horizontal speed? A horizontal range. Horizontal range is S equals to ut. And for the range, how far will this be? This will be ux times t. Ux is 40. T is? C and D will be a bit more complicated. Yes, right. Sorry? Do we know the height? What do you mean you ignore the height? You mean C? Hey, what's the height? That's exactly what you need to find out is S. How much distance you have fallen. Yeah. Minus, oh, okay, right. So S, how much is S? Tell me. 13? What is S? Oh, sorry, 78.4. Okay, so this is fallen from a height, which is, because it is from his hand, right? 2 meters above the ground. So exactly how much is this? So, okay, I'm sorry. This graph is a little bit wrong. This graph should look like this. And this is 2 meters. Okay, and then you calculate this S. This S is what? This S is from here all the way to the water. But the question, very good question, very good. Right, that you asked the right thing. So exactly what you're looking for this. So what is the correct answer? 76. So the correct answer for A is not 78.4, rather 76.4. Yeah, correct. The answer is 76.4. Horizontal distance, 160. Because this object is not fallen from the cliff, but rather it's from your hand. You throw it like this. And then you have 2 meters standing on the cliff. So you have to minus that 2 meters. So how do you solve C? What's the vertical component of velocity which the ball hits the water? So when this ball is fallen from the cliff, let's say from here, how fast? What would be the vertical V? So it's V because it's final speed. What's the Vy? How do you find Vy? Vy is affected by what? What affects Vy? There's one some G. Gravity. Gravity is the only thing that affects the value of Vy. As time goes by, your Vy will become faster and faster and faster. So what formula do you use? V equals to U plus AT. A is a gravity. They use negative because it is downwards. It's okay to use positive. I just want the value. So this will be how fast vertically when you hit the water. And they ask you what will be the angle, because when you travel like this, when you hit the water, it is not vertically downwards. When you hit the water at a certain angle. And how fast would it be? That depends on two things. It depends on the horizontal component as well as the vertical component. Do you know the horizontal component? When you hit the water? How fast is that? How much? Why? Because your horizontal speed will never change. Your horizontal speed is always 40. It doesn't change until you really hit the water. So it's 40. And your vertical speed, you just calculated 39. And which angle do you want to find? And what angle to the horizontal? To the horizontal is this angle. Okay, let's say this is a triangle. How do you find this angle? Theta. Tangent theta. Okay, method solution, know this. Tangent theta is 39.2 divided by 40. That's how you get the answer. Because it's a relationship of a tangent. I believe you are feeling the heat already. It's getting harder. It will get a little bit more complicated. I think we concluded the first two types of projectile motions. The first two types are the easier one. Okay, shooting at a certain angle. And these are the type of questions that usually comes out in the section B. So when the projectile motion is fired, it is not horizontal nor vertical. It goes with a certain angle. So when you have this angle, what happens is that it can always be split. So when you have a projectile like this projectile can always be split into two components. Because when you do this, it is easier for you to solve the problem. So let's say this is theta, and this is V. And what do we call this? V cosine theta. The horizontal component is a V cosine theta. And what do you call this? V sine. This is the protocol. Whenever you have a questions related to an angle, a projectile with an angle, you always do this first. Split them into two parts. I think this guy is quite amazing. Anyone do this? Quite amazing. I think my personal report was 5 only consecutively. I think I do this. That was a single. something I cut it because it missed after 31. But anyway, throwing basketball is a good example to talk about the third and the fourth kind of projectile motions. Because the ball doesn't start from the ground, and the ball goes with a certain angle. So what's the protocol? Whenever you're doing a question like this, we always start with splitting this vector into two components, horizontal and vertical. Because this will be much easier for us to analyze and then solve the problem. So as time goes by, what will happen is the horizontal speed of the ball will always be constant. It will never change. You look at the length, it stays the same, provided there's no averages. But your vertical component is always subject to change. When will you be the fastest? The beginning. In the very beginning, your vertical speed will be the largest. Then later on, because of what? Because you're going against gravity. You're going against gravity, what happens is your final speed will become lesser. So what formula is this? The formula is V equals to U minus GT. Or you can write plus AT is fine. Just remember, in this case, you're going against. So it's minus. So this U is the beginning. V is this one, or this one, or even this one. So when you reach the highest point, what is your vertical outward speed? What's your vertical outward speed when you are at the highest point? 0. That's when you stop momentarily vertically, then you drop again. So right after this, the formula will turn into what? V equals to U plus GT. So this half is V equals to U minus GT. This half is V equals to U plus GT. Because gravity is now adding into the speed. And then you just keep getting faster, keep getting faster, keep getting faster as you drop. So remember, every time you have a projectile motion with angle, the first thing you do is to split them into two components. V cosine and V sine. Okay. How do we make use of that to solve a problem like this? Now you have a stunt driver. This stunt driver goes at the speed of 22. And then what happened is, practice makes perfect. Very nice projectile. But I shouldn't assume, because I wouldn't know whether he will make it or not. Whether this journey will be a success depends on the speed and also the angle. Okay? These two factors will affect whether he will land here safely or maybe go into water, or maybe further away. So we have to calculate. So the question is, this is 50 meters. Will the driver make it? So what is the thing that we need to know, whether he can make it or not? Since we know the range is 50, so which means the range has to be at least 50. How to find the range? How to find the range? Range equals to speed times time. That's all right. What's the horizontal speed? We don't know yet, so you have to find out. You have to split this into two parts, which is given to you already. Okay? When we have a question with angle, remember, we always start with splitting the vectors. This is how? 40 degrees. This is 22. So what is this? 22 cosine 40. This is 22 sine 40. And then just use a calculator to find out the exact value. So this is approximately 17. This is how much? 14. Now, how do you find the range? Range, you're moving at a constant speed, right? What's the constant speed? Tell me, what is the horizontal constant speed? 17, approximately 17. So 17. Yeah, so what's the formula? The formula is Vt. So the range is equivalent to 17 times t. So the minimum value of r is 50. Okay? So actually I can change this to what? Greater than 50. Then it will be a success. But the thing is, what's t? We don't know the t yet. So you have to find out the t. How do you find the t? So which means you have to find out for this entire journey, how much time it will spend vertically. Okay? Because how much time it stays vertically is how much time it stays horizontal. This object is the same object. So this total journey, this time is the same time as it goes up and down. Do you agree? Because it's the same ball. So can I find out the time for the vertical motions? The time for the vertical motions and the time for the horizontal motions must be the same because it's the same ball. Okay, so now we know that your formula is this. 17 times t. I don't know the t, but I can find out the t from the vertical motions. I'm stuck with the horizontal already, so I need to make use of the vertical component. Okay, vertical component, what is my starting speed? 14. Okay, and then how high does it go? Do I know? Okay, I don't know the height, so I cannot make use of the height formula. What formula can I use? This formula I can use. V equals to U minus GT. Because I know that when I reach the highest point, what will be my V? What will be my vertical speed when I reach the highest point? My beginning starting speed, vertical, 14. Minus 9.8 t. Tell me, what's the t? How much? How much is the t? Simple, right? This is a very simple algebra calculations. So 14 divided by 9.8, how much is that? 1.42 seconds. So what does this time mean? This is the time taken for you to move from this point to the highest point, which is half the time of your entire journey. So what's the time for your entire journey? 1.42 times 2. So the total time taken is 1.42 times 2. How much is that? 2.84. Okay, now I know the time taken. 2.8. How much is this? Okay, now you need to travel at least how much horizontally to reach the target? 50. But you only managed to travel 48.28. I'm sorry, you'll be in the water. Because, so which means my projectile motions drawn over here is wrong. I assume wrongly. It should look more like this. Because it was not fast enough, or maybe the angle is not steep enough, whatever. Therefore, you'll go into water. The textbook, they use a slightly simple figure 48, but same results. So the unlucky stunt driver will fall short of the second ramp. Will go into the river. So this is how we can solve a problem that is a almost complete projectile. With this, try this by yourself. How to solve this? So this context is almost the same as this video clip. This guy hit a ball, and then this ball will travel like a projectile motion. So this is a projectile motor. Same height. You started from 0, you end at 0 height. That's all. Okay, I leave it to you. Try. What are the horizontal and vertical components? So basically, this is always the first thing you need to do. You have this. How much is this? This is 32. And then you need to find out what is the horizontal and vertical component. How much is this? This is 32. But don't use kilometer per hour. What must you do? So the first step you do is to convert it to meter per second. I've given the answer already. So 32 kilometer per hour is 8.89 meter per second. So this is actually 8.89. And how much is this? This is 25 degrees. So this is 8.89 cosine 25. And this is 8.89 sine 25. That will be the answer for the first two. Horizontal, vertical. And then B, how long does the ball spend for the entire flight? Means here, here. How much time it takes? C, what is the range? Try. So this answer is 8.06. 8.06 meters per second. And the vertical component is 3.75 meters per second. So this will be your first two answers. You get it? This one should be easy. Now, which component should you be using to find the flight time in this context? Which component? Which clue should I get? Should I use the horizontal or should I use the vertical to find the entire flight time? So, what are some of the formulas that you have? You remember what we did for the previous questions? So what formula should we use? And which component should we use to find the flight time? V equals to U minus GT. And we have to use a vertical or horizontal? Vertical. We have to make use of the vertical. So moving upwards. Because I know that when I'm moving upwards, when I reach the peak, what will be the V? 0. The Vy is 0. And what is the U? Or Uy? To be more specific. Vertical. What is Uy? 3.7. Minus 9.8 T. That's how you find the second. How much is it? 3.75 divided by 9.8. How much? 0.38. Is this the answer? No, this is not the answer. This is the answer of half of the time. So the total period is 0.38 times 2. That is the time taken for your entire journey. Because this is only the time for half of the journey. Now with that, you can solve C very easily. How to find C? C is a range. Range is the horizontal distance. And horizontal, you are just moving at a constant speed. So Vt. What's V? 8.06. What's T? You have just calculated. That's the answer. Check whether your answers are correct. Right, always change your answer to SI unit. Why? Because every single formula in VCE are established on SI unit. So if you use a non-SI unit for your calculations, your answer will be wrong. Make sure you change everything to SI unit before you apply the formula. That's fine. Okay. So you can write 0.77. It's fine. Is that clear? We have briefly addressed all 4 types of projectile moldings. Now take a look. I think we still haven't.
Time's up.
Oh, time's up. Oh, just nice. We finished the notes. So now you have to equipped with the knowledge to do these questions in your holiday booklet. Okay, so you have to equip with all the formulas that you need for your holiday booklet. Yes, I gave you on the first lesson. There's a very thick booklet, remember? There's the one with the train. If you lost it, there's some backup over here. Or you have not received, for those who are absent, please get it from me. Yes, correct. Alright, I'll stop here. I'll upload this notes on your Teams. Okay, I set up the Teams already for this class, so you can go and check. There's already some materials over there.